Good morning, Mike. It's great to have you here.
Good morning, Jane. Thank you for having me.
Let's start with a brief introduction. Can you tell me a bit about your background and experience?
Sure. I'm Mike, and I have over 8 years of experience in software engineering, with a strong focus on database management. I've worked extensively with SQL and NoSQL databases, including MySQL, PostgreSQL, MongoDB, and Cassandra. My experience includes designing database schemas, optimizing queries, and ensuring database security and performance.
That's impressive. Let's dive into some database-specific questions. Can you explain the difference between SQL and NoSQL databases?
Of course. SQL databases are relational databases that use structured query language, SQL, for defining and manipulating data. They are table-based and are best suited for applications requiring multi-row transactions, such as accounting systems. Examples include MySQL, PostgreSQL, and Oracle. NoSQL databases, on the other hand, are non-relational and can store data in various formats, such as key-value pairs, document-oriented, column family, or graph databases. They are designed to handle large volumes of unstructured or semi-structured data and provide high scalability and flexibility. Examples include MongoDB, Cassandra, and Redis. NoSQL databases are ideal for applications with changing data models or requiring fast access to large datasets.
Great explanation. How do you approach database schema design?
When designing a database schema, I start by understanding the requirements and data model of the application. I focus on defining clear relationships between different entities and ensuring data integrity through normalization, avoiding redundant data. However, I also consider denormalization in cases where performance improvements are necessary. I prioritize scalability and future growth, designing the schema to handle potential changes and increase data volume. Indexing is also a crucial aspect, and I carefully select indexes to optimize query performance while balancing write operations. Finally, I always include comprehensive documentation for the schema to ensure it is well understood by the development team.
That's a solid approach. Can you give me an example of a challenging database optimization problem you've encountered?
Sure. In one project, we had a PostgreSQL database that was experiencing slow query performance due to a large volume of data and complex joins. I started by analyzing the slow queries using PostgreSQL's Explain Analyze tool to understand the query execution plans. I identified that several queries were not utilizing indexes effectively, leading to full table scans. To address this, I created appropriate indexes on the columns used in where clauses and joins. Additionally, I optimized the queries by rewriting them to reduce the complexity and number of joins. I also implemented partitioning on large tables to improve data access times. These optimizations significantly improved query performance and reduced response times.
That's impressive. How do you ensure database security and compliance?
Ensuring database security and compliance involves several best practices. First, I implement strict access controls, granting the least privilege necessary to users and applications. I use encryption for sensitive data, both at rest and in transit, to protect against unauthorized access. Regularly updating the database software and applying security patches is crucial to protect against known vulnerabilities. I also implement auditing and monitoring to track database activities and detect any suspicious behavior. Compliance involves understanding and adhering to relevant regulations, such as GDPR or HIPAA. This includes data masking, anonymization, and ensuring proper data retention and deletion policies. Regular security audits and vulnerability assessments help ensure ongoing compliance and security.
Excellent. How do you handle database backups and disaster recovery?
For database backups, I implement regular automated backups, ensuring that both full and incremental backups are taken as needed. These backups are stored securely, often in multiple locations, to protect against data loss. For disaster recovery, I develop and maintain a comprehensive plan that includes the Recovery Time Objective, RTO, and Recovery Point Objective, RPO. This plan involves regular testing of backups to ensure they can be restored correctly and quickly in case of a failure. I also use replication techniques, such as master-slave replication or clustering, to ensure high availability and quick failover in case of a primary database failure.
Those are critical practices. To wrap up, where do you see the future of databases heading?
The future of databases is moving towards greater automation and intelligent systems. We'll see more databases incorporating AI and machine learning to optimize performance, manage resources, and detect anomalies. Hybrid databases that combine SQL and NoSQL capabilities will become more common, providing flexibility and scalability in handling diverse data types and workloads. Additionally, there will be a continued emphasis on distributed databases and edge computing to support the growing demands of IoT and real-time data processing. Security and compliance will also remain a top priority, with advancements in encryption and data privacy technologies. Overall, databases will become more adaptive, resilient, and capable of handling increasingly complex and dynamic data environments.
I completely agree. Thank you for your time and insights, Mike. It was great talking with you.
Thank you, Jane. I appreciate the opportunity and look forward to the possibility of working with your team.